Every day of your life is defined by choices. Some are monumental, like choosing a career, moving to a new city, or deciding who to marry. Most are entirely mundane, like deciding whether to turn left or right on your walk to work, or choosing what to eat for breakfast. We experience time as a single, unbreakable line. We make a choice, the timeline moves forward, and the unchosen options instantly collapse into nothing but imagination and memory. We call this reality. You are watching this video right now because a complex chain of choices, spanning back to the day you were born, led you to this exact moment. But what if every choice you didn't make is just as real as the one you did? What if, in another reality, you took that other job? What if you married someone else? What if, in a universe just slightly adjacent to ours, the asteroid that wiped out the dinosaurs missed Earth entirely? What if the universe we live in, with all its billions of galaxies and trillions of stars, is not the only one? Today, we are diving into the most mind-bending, controversial, and philosophically staggering concept in modern physics: the multiverse. For a long time, the idea of parallel universes belonged strictly to the realm of science fiction and comic books. It was a fun narrative device. But in recent decades, theoretical physicists have realized something startling. They did not invent the multiverse to write good stories. They stumbled into the multiverse because the mathematical equations describing our own reality practically demand that it exists. There's not just one theory of the multiverse. Depending on which branch of physics you study, there are actually 4 distinct scientific pathways that lead to the existence of infinite parallel realities. Let's start with the first, and perhaps the most terrifyingly simple version: the quilted multiverse. To understand this, we have to look at the limits of our vision. Our universe is roughly 13,800,000,000 years old. Because light takes time to travel, we can only see as far as light has traveled since the Big Bang. This creates a spherical bubble around Earth, about 93 billion light-years in diameter. We call this the observable universe. But what is outside that bubble? The overwhelming consensus among cosmologists is that the universe doesn't just stop. There is no brick wall at the edge of space. Space just keeps going. In fact, current measurements suggest that space is perfectly flat and extends infinitely in all directions. Here is where the math gets deeply unsettling. Inside our observable universe, there is a finite amount of matter. There is a massive but strictly limited number of subatomic particles: electrons, protons, and neutrons. Think of these particles like a deck of playing cards. A standard deck has exactly 52 cards. If you shuffle that deck, you get a unique arrangement. If you keep shuffling, you will get different arrangements. But because there are only 52 cards, there is a hard mathematical limit to how many unique combinations you can make. It is an unimaginably huge number, but it is finite. Eventually, if you shuffle the deck enough times, you will perfectly repeat an order you have already dealt. Now, apply this logic to an infinite universe. The infinite quilt. If space goes on forever, and the number of ways you can arrange particles is finite, then physics dictates that the arrangements of matter must eventually repeat. If you travel far enough into the infinite expanse of space, you will eventually find a region where the atoms happen to assemble themselves in the exact same pattern as our observable universe. you will find another Milky Way, another Earth, and another you, sitting in the exact same chair, watching this exact same video. And because the universe is infinite, there is not just one copy of you. There are infinite copies. Some are identical down to the last atom. Others are completely different because of a single shifted electron. In one distant cosmic patch, you are the president of the world. In another, you were never born. This isn't science fiction. It is a basic mathematical certainty of an infinite, flat universe. But the quilted multiverse is just the beginning. The second pathway to parallel worlds comes from the very birth of reality itself. It is known as the inflationary multiverse. As we explored in a previous journey, immediately after the Big Bang, space underwent a period of violent, exponential expansion called cosmic inflation. The universe stretched faster than the speed of light, smoothing out reality and setting the stage for galaxies to form. But the physicists who developed this theory, like Alan Guth and André Linde, discovered a flaw in the math. Or rather, a feature. Quantum mechanics suggests that inflation is not something that happens once and stops everywhere simultaneously. Instead, inflation is eternal. Eternal inflation. Imagine a giant ocean of boiling water. The water represents an expanding high-energy quantum field. As the water boils, bubbles form, expand, and drift. In this analogy, the entire observable universe we live in is just the inside of one single bubble. Our Big Bang was simply the moment when inflation stopped locally, allowing matter and energy to cool and form stars. But outside our bubble, the infinite ocean continues to boil. It is eternally expanding and creating billions, trillions, an endless number of other bubble universes. Each of these bubbles might have entirely different physical laws. In one bubble universe, gravity might pull twice as hard. In another, electromagnetism might not exist at all, meaning light cannot form. Most of these universes are completely dead, dark, and empty. But with infinite bubbles popping into existence for eternity, every possible variation of physics is playing out somewhere in the massive cosmic foam. The third pathway to the multiverse is the most famous and perhaps the most deeply personal. It does not deal with infinite distances or cosmic bubbles. It deals with the microscopic world of quantum mechanics. This is the many worlds interpretation. To understand this, we must look at the most famous thought experiment in scientific history, Schrödinger's cat. In the 1930s, physicist Erwin Schrödinger proposed a scenario. Imagine you place a living cat inside a sealed steel box. Inside the box, you place a tiny piece of radioactive material, a Geiger counter, and a glass vial of deadly poison gas. If the Geiger counter detects that a single atom of the material has decayed, it triggers a hammer, breaks the glass, and the cat dies. If the atom does not decay, the cat lives. According to the bizarre rules of quantum mechanics, before you open the box to look, that single radioactive atom exists in a state of superposition. It is both decayed and not decayed at the exact same time. It is a blur of probability. Therefore, until the box is opened and measured, the cat inside is simultaneously dead and alive. When you open the box, the universe forces the atom to make a decision. The wave of probability collapses, and you see either a living cat or a dead cat. For decades, this collapse of probability frustrated physicists. It didn't make logical sense. Why does human observation force the universe to choose one outcome over another? In 1957, a brilliant young physicist named Hugh Everett proposed a radical solution. He argued that the probability wave never collapses. The universe doesn't choose. Instead, the universe splits. The many worlds interpretation. When you open the box, you do not force reality into a single state. Instead, reality branches into two separate, parallel timelines. In one universe, you open the box and find the cat alive. In an entirely new, separate universe that just branched off, a perfect copy of you opens the box and finds the cat dead. If Hugh Everett's many worlds interpretation is correct, the implications are absolutely staggering. It means that every single quantum event, every movement of every electron, every flip of a coin, and every choice you have ever made physically splits the universe. Every time you face a decision, reality fractures. You're constantly generating billions of parallel universes just by existing. There is a universe where you stopped watching this video 5 minutes ago. There is a universe where you dropped your phone and broke the screen today. There is a universe where every risk you ever avoided actually happened. You only experience this one specific timeline because your consciousness is riding a single, narrow branch of an endlessly growing cosmic tree. The fourth and final pathway comes from the highest, most abstract realm of theoretical physics: string theory. String theory attempts to unify all the forces of nature by suggesting that the fundamental ingredients of reality are not particles, but microscopic, vibrating strings of energy. But the mathematics of string theory require something bizarre. They require a universe with 11 dimensions. Because we only experience 3 dimensions of space and 1 of time, the other 7 dimensions must be folded up, or they must exist on massive, multidimensional membranes. Physicists simply call them branes. The brain multiverse. In this model, our entire observable universe is just a 3-dimensional surface, a single sheet of paper floating in a much larger, higher dimensional space called the bulk. And we are not the only sheet of paper. There could be an infinite number of these branes, hovering millimeter fractions of a dimension away from us. Imagine holding a newspaper. You are a 2-dimensional character printed on page 3. You can move up and down, left and right across your page. But you have absolutely no idea that page 4 exists, hovering right next to you. It is practically touching you, yet it is completely invisible and inaccessible because it exists in a spatial direction you cannot perceive. Parallel universes might not be billions of light years away. They might be hovering right next to you, floating in a higher dimension, separated by a distance smaller than an atom. So, with all these theories, is there any actual proof? Can we ever see these other universes? By definition, a parallel universe is disconnected from our own, making it impossible to directly observe. However, cosmologists have proposed that we might find scars from the multiverse. If the eternal inflation theory is correct, and we live in a bubble universe, it is possible that our bubble might have collided with a neighboring bubble shortly after the Big Bang. This cosmic collision would have left a massive, circular bruise on the cosmic microwave background radiation, the heat signature left over from the birth of our universe. Telescopes like the Planck satellite have mapped this radiation and astronomers have actually found strange, unexplained cold spots that some boldly argue could be the faint impact craters of parallel universes bumping into our own. As of today, the multiverse remains a theory. It is the absolute edge of human comprehension. But if it is true, it forces us to ask a profound philosophical question. If there are infinite versions of you, playing out every possible variation of your life, does that make your choices here, in this universe, meaningless? Many would argue the exact opposite. Out of an infinite sea of possibilities, out of countless branching timelines and quantum-splitting realities, you're the only one walking this specific path. The choices you make are uniquely yours in this exact configuration of the cosmos. The multiverse doesn't diminish your reality. It makes the specific timeline you're experiencing right now a rare, mathematical masterpiece. So, choose carefully, because somewhere out there, another version of you is doing the exact opposite.